Yeah, good morning, my students. Now I'm going to discuss on the crystal structures. This video number 5. Okay. Today's discussion is purely on the Bravais lattice and also Miller indices. I think probably you're studying the concept of Miller indices and Bravais lattice even in chemistry also. Quickly, I will recapitulate the things what I discussed yesterday. In yesterday's discussion, I said that it is a unit cell. It is a unit cell. Again, in the unit cell, they are classified into what? Primitive and non-primitive cell. Primitive means where atoms are present only at the corners. Here. See, atoms are present only at the what? Corners here. In the three-dimensional picture, I explained that this atoms, 8 neighboring atoms. It is as good as, suppose I give the one fruit, you share it among 8 students. Then each student will get how much? 1 by 8. You will get 1 by 8 you will get. Here, it is 1 by 8. Like that, how many corners are there? 8 corners are there. 1 by 8 into 8 equal to what? 1. That means the unit cell which contains, that is for simple unit cell, which contains how much it is? Only one atom per unit cell. Only one atom, that is. Next one is non-primitive cell. I said that. In case of non-primitive cell, you see the atoms are present not only at the corners, they are present at these edges also. In the middle also, they are present. Or at the center also, they are present here. Then such cells are called as what? Non-primitive cells here. Non-primitive cells. I said that. Suppose this is the one unit cell, corners, corner. Apart from that, one atom is present even at the what? Center. Then this cell is called as a what? Non-primitive cells. Okay. Next, with this idea, now I proceed for today's discussion. Okay. Even in the two-dimensional picture also, I explained that. Here I have taken the two-dimensional picture. Here it is only 4 corners are there. First corner, second corner, third corner, fourth corner. The atom which is present in this corner now, that is atom which is present in this corner, it is shared with, this will be shared with this unit cell, this unit cell, this unit cell, this unit. So the contribution is what? Only what? 1 by 4 days. But like that, in the two-dimensional, we have how many corners are there? 1, 2, 3, 4. So that it is multiplied by what? Multiplied by what? 4. Multiplied by 4 equal to what? 1. Normally, it's very easy to understand two-dimensional figure compared to what? Two-dimensional picture and all that. Now, next, let us come to this one. Here, all unit cell, that is explained by the what? Namely, 6 parameters. They're explained by the 6 parameters. One is x, orthogonal, that is coordinates, x direction, y direction, and another one is what? Z direction. Remember, these are called as a crystallographic axis. Crystallographic axis. Any unit cell is represented by the 6 parameters. One is x, y, and what? Z direction. As you know that in the vectors, along x-axis, the unit vector is A. Along y-axis, unit vector is B. Along z-axis, the unit vector is what? C, that is. And next one is C. Here, you close this A, you close it. You close it. The angle between other B and C is angle between this and this. This and this. This angle, I will call it as a what? Alpha. This is called as what? Alpha. Next, angle between Z and x-axis. This is what it is represented by what? Beta. And similarly, angle represented by x and y is represented by what? Gamma. These are the totally 6 parameters by which we are representing the any unit cell, size of a unit cell, that is. Okay. With this idea, in the crystal system, there are seven different types of crystals are there, students. Yes. Here, one is crystal system, unit vector, and angles, I say. Cubic one. Cubic means A equal to B equal to C. All are what same only. X-axis, Y-axis, and Z-axis. A, B, and C are equal. And alpha equal to beta equal to gamma equal to what? 90. It is sometimes it is called as a simple cubic also. It is also called as a simple cubic. Students, remember, if any one of the parameters differs, either in the unit vector or in the angle, then the crystal is also, type of the crystal is also what? Different. Next is tetragonal. Next is orthorhombic, monoclinic, triclinic, trigonal, hexagonal. How many are there? There are 27. Crystal, cubic, tetragonal, orthorhombic, monoclinic, triclinic, trigonal, hexagonal. I have written in the particular order. Just you only should remember according to your 10 minutes. We should remember. You see, if any here and here, you see tetragonal. A equal to B, but B and C are not equal. And also alpha equal to beta. That is both are same angle, but gamma equal to how much it is? 90° and all that. Alpha equal to beta equal to gamma equal to 90. This also, these two are same, but here what is different? B and C are not at all same here. For example, orthorhombic. A is not equal to B is not equal to what? C. But alpha equal to beta equal to gamma equal to what? 90°. In this fashion, that is what the people distinguished or identified. There are 7, that is what crystals are there. Again, 7 crystals are there. Next, students. Again, in the simple cubic or orthorhombic, what are this? Again, we are classified into 3 types. One is a simple cube, simple cubic. It is represented by B. It is represented by what? Simple cubic structure is represented by what? P it is. The unit cell of simple cubic has 8 lattice points at the corners of the cube. You see, corners 1, 2, 3, 4, 5, 6, 7, 8. As I told you earlier also, the contribution made by this cell, because again, I can keep one more cell here, one more cell here, one more cell here, like that. Easily you can understand in 2-dimensional, easily you can understand here, here. Now, that is one 2-dimensional picture. That is another unit cell. This is what? Another unit cell. This is what? Another unit, like that. No? And this corner is there. Now, this corner is shared by this, 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 and this. Here it is 4 corners are there. But in the simple cubic structure, in the 3-dimensional picture, it is 8. That's why we have written 1 by 8 into what? 8 equal to 1. This is the story of what? Simple cubic structure. And how it is represented here? It is represented by what? P. That is next is. Next one is face-centered cubic structure. Face-centered. I'll tell you that it's face-centered. Now, 1 minute. Face-centered. Okay. You see here. Apart from that, each face, cube has got 6 faces are there. Imagine your textbook that is. In the textbook there are totally 6 faces are there. 1, 2, 3, 4. Behind that 5, and here it is what? 6. Totally 6 faces are there. Yes. Apart from that, corners. And in each face at the center, there is what? One atom is what? Present here. That is now. Yeah. 1 minute. Now. Okay. You see? Here it is represented by, now this is represented by F. Face centered is represented by what? F here. That is. I have written the text. The unit cell has 14 lattice points. That is 8 points at the corners of the cube and 6 at the what? Center. Totally how many lattice points are there? 14 lattice points are there. If you want, you can calculate 1, 2, 3, 4, 5, 6, 7. Here behind it is what? 8 are there. And on each face, 1, 2, 3, it is 4, 5, and this is what? 6. Now, what is the contribution here? Here, that whatever this face is there, no, this face is it is just to keep one book and another book, you just to touch at each other. That is now here. First corner is what? 1 by 8 into what? 8 plus 1 by 2 into 6. Why it is 6 here? Totally 6 faces there. But in each face, it is contributed by what? It is contributed by the what? 2 faces here. For example, I'll show you this now. This is one face, this face. And another cell that is I'm writing here, this one. This face, whatever this cell is there, no, this will be contributed by this face and also what? Contributed by what? This face here. So that's I have written here 1 by 2. 1 by 2 into 6. 1 by 2 into 6 equal to what? It is 3. 3 plus 1 equal to 4 here. Base centered cubic structure. In how many lattice points are there? Number of atoms are there? Here 4 atoms are there in this. Here, clearly you can understand also. Suppose this one apple is there. This apple is cut into 2 parts. It is, you see, is it not, Sabi? It is what? Off portion of the apple here. Because here it is one more, the face is there. Here also it is shared with what? One more, the unit cell that is. That's why you are written 1 by 8 into 8 plus 1 by 2 into 6 equal to what? 4 apple. Next one. It is very easy to understand. Body centered unit cell, it is BCC. It is called as what? BCC. At the center, there is only one atom. Totally, how many atoms are there? 8 atoms are there. 8. That is at the corners. There are 8 corners of the cube and 1 lattice point at the what? Center. Then what is its contribution? 1 by 8 into 8 plus of 1 equal to what? 2. For the what? Body centered. At the center of the body, there is one cell is there. Next one. Base centered. It is called as a base centered. Base means here above, that is table top, and table down, that is what? 1, that is here. And apart from that, corners are there. 1, 2, 3, 4, 5, 6, 7, 8. What is the contribution here? 1 by 8 into what? 8 plus 1 by 2 into 2, because this is one face and this is what? Another face here. Not necessarily here. Here you can keep one more cube, you can keep it here. One more cube, and here also I can keep one more cube, so that this atom will be shared between this cube and also this cube. So that contribution is only what? 1 by 2 into 2 equal to what? 2. That is. This is the story of a base-centered cubic structure. Students, it is not necessarily here, student. The atom may be present this face as well as this face. Opposite faces, it may be present. Getting the point? Totally, that is, one is what? Simple cubic. Next is simple cubic. It is represented by what? P. How many atoms are there? Only one atom is there. Next is face center. In the face center, it is how many atoms are there here? It is totally, it is represented by F, and totally how many atoms are present? 4 atoms are present. Next is body center. It is only 2 atoms are present. Similarly, in the base center, here also it is 2 atoms are present. I think you got the point. Here, what are that? One is simple cubic. Next is base center. Next is what? Body center. Next one is a base center. Okay. Now, based on this, the Bravais he identified the 14, that is what? Space lattices he identified. In 1848, the French crystallographer Bravais showed that there are only 14 possible types of space lattice in the 7 systems of the crystal here. Already said that 7 crystals. I said that one is simple cubic, orthorhombic, triclinic, hexagonal. I told you, like that. Here you say simple cubic, and here also it is cubic. Here also it is what? Cubic. In the cubic, one is simple. Next is face center. Next one is body center. Again, in the cubic only, it is classified into how many types? 3 types here. And body centered, it contains how many atoms are there in the body centered? In the body centered, I told you that is this body center, it contains 2 atoms. How it is? 1 by 8 into what? 8 plus of what? 1 equal to what? 2. That is I told you. For the face centered, that is for the face centered, I told you that is a face centered cubic. Here 1 by 8 into what? 8 plus 1 by 2, because 6 faces are there, equal to 1 plus 3 equal to what? 4 are there. Next, in case of simple cubic, in this case only what? 1 by 8 into 8 equal to only what? 1, that is only 1 lattice point is only 1 atom. Only 1 atom is what? Present. In this fashion, that is 1 minute. Yeah. Next, again tetragonal. This also what? Tetragonal. In the tetragonal, 2 types. One is simple cubic and another one is what? Body centered. Next one is hexagonal. In hexagonal, there is only one category is there. That is cubic. Only atoms are present only at the what? Corners. Next, come to the orthorhombic. Orthorhombic. You see, in the orthorhombic, there are 4 categories. One is simple cubic, body centered, base centered, and it is what? Face centered. You see, in the orthorhombic, there are 4. All are present. Simple cubic, body centered, base centered, and what? Face centered. Next, come to the rhombohedral. In the rhombohedral, that is only one type. Only atoms are present only at the what? Corner. It is just like a cubic structure. Next, monoclinic. In the monoclinic, there are 2 types. One is only atoms are present at the what? Simple monoclinic. And another one is what? Look at this diagram where the atoms are present only in the top, and it is what? That is what? At the bottom. This is called as in what? Base-centered monoclinic. Next one is a triclinic. In the triclinic, the simple triclinic. Here there is no question of face-centered, body-centered, and what? Base-centered. Okay, in the Braves, they identified how many there is space lattice here. There are 14 space lattice he identified. Next, that's the same thing I explained with the table lattice. Next, now procedure to find the Miller indices. Okay, what is Miller indices? I'll tell you later. I have to give you one example. Otherwise, you can't understand what is Miller indices. Definitely, you will not understand. First, identify the plane. First, identify the plane of intercepts on the x, y, and z axis. 1 minute. Then take the reciprocal of the intercept. Next, convert into smallest integers. Next is h represent a reciprocal on x-axis, k represent reciprocal on y-axis, then l represent reciprocal on what? Z-axis. First, identify the plane intercept on x, y, and z axis. It's one diagram. Here, you students, you see, this is x-axis, this is y-axis, and this is what? Z-axis. Okay. Along x-axis, where it is intercept? Here you see, one lattice point here. It is second lattice point here, and this is what? Third lattice point along the x-axis. Along y-axis, you see, one lattice point, second lattice point. Along z-axis, you see, this is one lattice point, this is another lattice point. Now you say, This crystal is now it is intersecting. This is one plane. This is one point. Along y-axis at this point it is intercepting. Along z-axis it is intercepting at this point. Yesterday I told you this. From here to here it is 1a. And here to here it is what? From here to here it is 2a. From here to here it is what? 3a. 3a. Now the intercept on the x-axis is 3, that is. I think you understood this. What are the intercept on the x-axis here? This plane, this is one plane, students. This is one plane. This is one plane. This is one plane. Where it intercept on the x-axis? 3. 3a. On the y-axis it is what? It is 2b. On the z-axis it is what? It is 2c. That is. I hope that you understood this. This is one plane. It is one plane. This is one plane. Of course, I will discuss several examples. I will discuss it. If not this, in second example, you understand. Take the reciprocal of it. Take the reciprocal of it. What is the reciprocal of 3? 1 by 3. What is the reciprocal of 2? 1 by 2. What is the reciprocal of C? 2. It is 1 by 2. Then take the LCM of it. 3, 2. LCM is what? 6. Then you are getting what? 2, 3, 3. I think you know LCM and all that. I'm not going to explain LCM and all that. Here, 1 by 3, 1 by 2, 1 by 2. Then by taking the what? The smallest integer, I think it is 1 minute here. It is 1 by 3, 1 by 2, and this is what? 1 by 2. That. What is the LCM of this? 6. So that it is 2. I think you did in the primary school. 3. This is 3. Then you are getting 2, 3, 3. That is what? It is. Now, Miller indices for this smallest integers are 2, 3, 3. So that Miller indices for 2, 3, 3. This is the Miller indices. We should represent like this. Better to represent in the square bracket also can represent. Next, student. I'll give one more example. Here, this plane, you see, this is the one plane. This is the origin. It is one lattice point. From here to here, it is what? A. It is here to here, it is what? A. But now it is intercepted not at this point in the middle, it is intercepted. It is intercepted in the middle, that is. It is intercepted in the middle here. Here it is intercepted. So that I have written it as 1 by 2, that is, I have written 1 by 2 here, 1 by 2. And along y-axis, you see, from here to here, that is one lattice point. Here, from here to here, 1b it is 1b. But here it is where it is intercepted here in the middle. It is intercepted. It is almost in the middle. So that this value is 1 by 2. Similarly, along z-axis, you see, along the z-axis. This is the z-axis. Here, it is the origin. Next lattice point is here. Here it is C. From here to here, it is what? C. From here to here, origin it is C. But now it is intercepted. Where it is intercepted? In the middle, it is intercepted. So that this value is also what? 1 by 2. What is the next procedure? Take the reciprocal of it. Reciprocal means 1 divided by 1 by 2. How you are writing? A. That is, x is there. What is reciprocal? 1 by x. Like that. Similarly, this also 1 divided by 1 by 2. 1 divided by 1 by 2. Is it not the reciprocal of? Then simplify it. Then where the 2 goes here, in the numerator it goes here. So that I have written 2, 2, 2. Then what are the Miller indices for this is? It is 2, 2, 2. 2 represents H. This 2 represents K. This represents what? Yeah. These LKL values are called as in what? That is called as in what? Miller indices. Miller indices. By chance, students, if it is intersected at this point, one minute, yeah. If it is intersected at this point, this point, this point, and this point, you see, at the time your plane is like this. Plane is like this. Then I highlight it. This portion. In that case, x-axis a. 1 minute. Now, x-axis is what? 1. Y-axis 1. Z-axis 1. Then take the reciprocal of it 1 by 1, 1 by 1, 1 by 1. What are the Miller indices? It is 1, 1, 1, 1. These are the Miller indices for this. Here, see, I give an example here. One more, the crystal structure. See here. This is x-axis. Of course, are not extended. This is x-axis. Where it is intercepted here? At this point, one lattice point. Along y-axis, this is y-axis. At this point, one lattice point. Along z-axis, this is one lattice point. So that this is the plane that is represent this plane that is highlighted. This is the plane. See, this is one plane. Actually, it is 1 minute. This is x. This is y, and this is what? Z. And what is this plane Miller indices here? 1, 1, 1. If you want, you can look into this animation. You can look into it here. Yeah, 1 minute. Complete. 1 minute. Okay. Anyway, now this is the Miller index. I given explained with the 2 examples I explained here. This is the concept of Miller indices. And here you see where it is intersected 1 by 2. It is also 1 by 2. This is also what? 1 by 2. The reciprocal is 1 divided by 1 by 2 equal to what? 2, 2, 2. Now, I think you understood this. What is the procedure here to find this? First, identify the plane intercept on x, y, and z axis. Take the reciprocal of the intercept. Then convert into smallest integers. Then x represents reciprocal of x, k represents reciprocal of y, and L represents reciprocal of z axis. So, thank you. Now I'm going to end this session here, and with some more examples tomorrow, I'm going to continue the discussion of Miller indices. Thank you, one and all.